So, students, good morning. So almost we have finished theoretical part and illustration examples given in the text. But we know that we have to do little bit additional also. So today we discuss extra theoretical part and also will solve the problems. So in this present lecture, we discuss if we have dipole means magnet, this is north, this is south, then what is the magnetic field here? That you know it is on the equatorial line. So BE is equal to mu 0 upon 4 pi m upon dq. And if you take this point here on the axis, so we have B axis is equal to mu 0 upon 4 pi 2m upon dq. Okay. આનું બીજું નામ છે end on position. End on position કોઈ ટેક્સ્ટ ની અંદર રેફરન્સ માં આવવું હોય end on position, and this is called broadside position. Broadside position. Okay. Now, where is the what is the magnetic field at this point? Suppose for comfort I take this side south and this side north. So this is my direction of the magnetic dipole, and I am taking point somewhere here. Then what is the magnetic field at point P? That we want to find it out. It is very similar to the electric dipole, first of all. It is very similar to electric dipole. So what we do, this angle is theta and distance is d. So we take, this is the vector quantity, magnetic moment is vector quantity. So I take this magnetic moment along this line. So અહીંયા હું એક component લઈ લો એનો, and this is called theta near means m cos theta. So we can imagine that instead of m we have m cos theta, and we finding magnetic field at P. This is along the axis. Okay. So magnetic field at P due to m cos theta. So we have B, I say 1P is equal to mu 0 upon 4 pi, and this is the line, so it is axis formula, so I have 2m cos theta upon dq. Okay, and this will be along this line, r direction magnet. This is B1P. Same thing we take perpendicular component, so that is this component, and this is nothing but m sin theta. This is m cos theta, and this is m sin theta. So magnetic field at P due to m sin theta. So let us say it is B2P is equal to mu 0 upon 4 pi m, because it is now equatorial line for m sin theta. So m cos theta upon dq. So that is in this direction, along this direction. So this is B2P. Okay. B2P. So both vectors are mutually perpendicular, so we get resultant of B1P and B2P. I say let us be root of this one, square of this plus square of that, and that would take the root of that. So the mu 0 4 pi is common, so I take mu 0 upon 4 pi common. M is also common. dq is also common. Then in the roots of that, what we get? Square of this, so 2 square means 4 cos square theta, and square of this, I made mistake, it's sin theta. This is sin theta because it is m sin theta. M sin theta. So plus sin square theta. So what we get, mu 0 upon 4 pi m upon dq root of cos square plus sin square 1 hai, and still we have 3 cos square theta, so 3 cos square theta. So this is the magnetic field at point P. So it is very similar to, you must be knowing this Kp upon Rq square root of 1 plus 3 cos square theta. So એના જેવી જ ફોર્મ્યુલા થઈ ગઈ, આ તમારે યાદ રાખવાની થશે. So when you have point which is not on the axis or not on the equatorial line, it makes certain angle. We do this calculation. Okay, it's very important formula. Now what is the angle of that? Where is it? So here હું એક angle લઈ લઉં છું. So this is the resultant magnetic field here, P. This is our B, P, and this angle is, I say, alpha. Okay, along this line, along that line. So tan alpha is equal to what? So you can write tan alpha is equal to opposite side is B2P, B2P, B2P. This is that one. So this upon that. So you will be this upon this. Okay. 2 upon 1. So all this cancel, you will be half. So મને શું મળશે? Half મળશે. Tan alpha is equal to half. અને મારે જોઈએ છે થીટા સાથે રિલેશન. Half sin theta and cos theta. Okay, yes, sorry. Sin theta into tan theta, yes. So here is sin, in first equation is cos, so it becomes tan theta. So this is the relation, alpha is making half tan theta. So total કેટલો angle થાય તમે જુઓ. So this angle is theta, and again with respect to that it is alpha. So along m કેટલું થશે? તો આ લાઈન કેટલું બનાવશે એંગલ? તમે જુઓ, this angle is alpha. This angle is alpha. તો અહીંયાથી મારો કયો એંગલ બનશે? થીટા પ્લસ આલ્ફા. along મેગ્નેટિક મોમેન્ટ કેટલો એંગલ થશે? આલ્ફા પ્લસ થીટા. તો એક આ વાત તમને કરવાની છે. What is the magnetic field at certain angle with the magnetic moment? Okay. Now we discuss magnetic potential. This is not discussed in the text. Magnetic potential. So magnetic potential, suppose you have magnet, this is the magnet, and this side north, this is south, and this distance we know it is 2L, and we take one point here along the axis. How far is from this point? It is D. So what is the magnetic potential because of the magnet at this point? So as because of charge we have electric potential. Similarly, we have because of pole strength we have magnetic potential. So અહીંયા magnetic mole strength m છે, અહીંયા બી m છે. This is very similar to the positive charge. This is similar to the negative charge. Okay. So potential at P due to north pole. So I say it is V1P is equal to mu 0 upon 4 pi. It is KQ upon R. Similar to K means mu 0 upon 4 pi. Q like M upon distance. અહીંયાથી અહીંયા સુધીનું distance કેટલું થશે તો કે D minus L. Similarly for south pole, magnetic potential due to south pole. So V2P, sorry, this will negative mu 0 upon 4 pi M upon D plus L. So total magnetic potential V is equal to V1P plus V2P. So we get mu 0 upon 4 pi, M is the common, 1 upon, small m is the common, small m is common, 1 upon D minus L minus 1 upon D plus L. Now we mathematics now use કરીશું અને we get it mu 0 upon 4 pi M. So here D plus L, D minus L, D will cancel out, I think. And this minus minus become 2L. So this is 2L upon D square minus L square. And this is nothing but mu 0 upon 4 pi. M2L means magnetic moment upon D square minus L square. So this is the basic formula for magnetic potential. But if D is very large compared to L, we can write mu 0 upon 4 pi. We get M upon D square for D is very greater than L. Okay. We are derived for right side. We can derive for left side also. This is this will positive. This is negative. Denominator में कोई फेर पड़वानो नहीं. एक negative sign आवश्यक कदाच. બીજો ફેર પડશે નહીં. Okay, so this is the potential because of the magnet at a given point. અને આના પરથી આપણે એવું કહી શકીએ અહીંયા હું કોઈ પણ પોઈન્ટ લઉં at equal distance here or here or here તો મને શું મળવાનું છે 0 મળશે કારણ કે બે ડિસ્ટન્સ સરખા છે, રાઈટ? તો અહીંયા કોઈ પણ આપણે પોઈન્ટ લઈએ where we get potential 0 કારણ કે અહીંથી equal distance થતું છે. ઓકે, તો હવે હું એક પોઈન્ટ અહીંયા લઉં છું. I take another figure. Suppose this is my magnet. Okay, this north, south, whatever it may be, and I take point somewhere here, which makes angle theta. Actually, I have to take with respect to magnetic moment. એટલે હું થોડું ફેરફાર કરી નાખું છું. This is north and this is south. એટલે તમને સમજવામાં easy પડે. થીટા નકર મારે આ બાજુ થીટા લેવો પડે. Okay, so what is the potential? So I have to take only perpendicular component, sorry, parallel component. તો આ મારું શું થશે? This is my m sin theta and this is my m cos theta, m cos theta, right? So because of m sin theta, potential is 0 करके आज a point say it is at equal distance from both the sides. So due to m sin theta, v equal to 0, and due to m cos theta v કેટલું થશે મારું તો કે mu 0 upon 4 pi અને આ જ ફોર્મ્યુલા મારે વાપરવાની પણ m ની જગ્યાએ શું યુઝ કરવું m cos theta upon dq અને આ બી તમે ઇલેક્ટ્રિક પોટેન્શિયલમાં મેળવેલો હશે જ તે અને ધીસ ઇઝ ઇઝી મેથડ ટુ ફાઇન્ડ આઉટ ધ ઇલેક્ટ્રિક પોટેન્શિયલ ત્યાં બી તમે અહીંયા આમ લીધું છે પછી અહીંયા લીધું છે એવું કરેલું હશે but this is easy way to find out the electric potential also. Okay, so now suppose I have two magnets, 1 and 2, and magnetic moment m1 and m2, and distance between their center is d. Okay, so how they interact? So પહેલા તો એમ કે આનું magnetic field અહીંયા produce થશે along the axis, so we can write b at 2 due to 1, I say it is b1. So b1 is equal to mu 0 upon 4 pi and it is 2 m1 upon dq. We neglect this length of the magnet compared to d, and this will be along right side in right direction because south north direction. Okay, amaru b છે, and then because of this field b1, now magnetic moment m2 is placed. What is the angle between these two? So angle is 0, so torque is 0. So torque on 2 due to b1 or means first magnet is 0. Torque on 2 because of 1 is 0. Okay, torque 0 થઈ જશે. What is the force though? So force મારે calculate કરવો તો first I write potential energy. Potential energy, that is U2 is equal to minus m dot b. So m2b1. Okay. So what is this direction? m2b1. So angle theta is 0. So I write directly mu 0 upon 4 pi 2 m1 m2 upon dq. Isn't it? Isn't it? એવું થશે ને કારણ કે અહીંયા આગળ એંગલ થીટા 0 થવાનું છે. ઓકે, અને હવે now we find out what is the force. કઈ રીતે? તો આપણે જાણીએ છીએ કે F2 is equal to minus du2 by dd. ડિસ્ટન્સ છે ને, ડિસ્ટન્સના વેરિએશનમાં. So if you differentiate this, તો મારી પાસે આવશે mu 0 upon 4 pi. This is 2 m1 m2 and d is going up, so it is minus 3 multiple થઈ જશે, so it is plus 3 and this negative એટલે અહીંયા કે વધારાનો 3b આવી જશે મારી પાસે and upon d4 થઈ જશે. So it comes out to be mu 0 upon 4 pi 6 m1 m2 upon d raised to 4. So this is the force on the second magnet because of the first one. So ये તમે જોઈ શકો છો F2 is proportional to 1 upon d raised to 4. જ્યારે અહીંયા magnetic moment આપણે લીધી હોય ત્યારે m1 m2 magnetic moment છે. Okay, so this is very important relation. Now depending on the direction it may be positive or negative. Here we are getting positive કારણ કે આપણે અગેન્સ્ટમેન્ટ આવી કરી હતી એટલે આપણું પોટેન્શિયલ એનર્જી કેવી આવી હતી? નેગેટિવ આવી હતી, નેગેટિવ. પણ જો અહીંયા નોર્થ અને સાઉથ હોત તો થીટા ત્યાં આગળ કે 180 લેવો પડે અહીંયા આગળ, તો 180 લે તો આ પોઝિટિવ આવી જાય, આ પોઝિટિવ તો આ નેગેટિવ આવે. તો અહીંયા નોર્થ અને સાઉથ વચ્ચે આપણે વીનો એટ્રેક્શન થાય એટલે વી આર ગેટિંગ
So this method we use whatever the position of the magnet. Suppose magnets are parallel, is they are kept એના બે પોઈન્ટ છે મેં સેન્ટર અને આવી રીતે આપણે એને મૂકેલા છે. One side is north south. So this magnet is 1, this magnet is 2. So we find out what is the magnetic field of 1 at position 2. તો સાઉથ થી નોર્થ મેગ્નેટિક મોમેન્ટ હોય તો અહીંયા તમે જુઓ તો મેગ્નેટિક ફિલ્ડ કેવું હશે? ડાઉનવર્ડ હશે, right? It is downward. So first we find out magnetic field B1 and then we apply uh, this formula of the potential energy. તો અહીંયા M2 કેટલું થશે? સાઉથ ટુ નોર્થ. તો બંને વચ્ચેનો એંગલ કેટલો થયો? 180 ડિગ્રી. તો આમ 180 ડિગ્રી સો ટોર્ક નહીં લાગે. And you can calculate potential energy. Also you can calculate force also. Once you get the potential energy, then you differentiate du by dt with negative sign, you will get the force. So first magnet, no, what is the magnetic field here? So mu 0 upon 4 pi m upon dq with negative sign. Okay, અહીંયા m આવશે, અહીંયા આગળ અને એક્સિસ ઉપર હોય તો શું આવે? 2m આવે. તો આ મેથડથી આપણે f શોધી શકીએ. ફર્સ્ટ વી ફાઇન્ડ આઉટ u અને u નો ડિફરન્શિએટ કરીએ તો f મળી જાય. આવી રીતે હોય. સપોઝ બોથ આર પરપેન્ડિક્યુલર ટુ ઈચ અધર. ઓકે, તો this is my first magnet, this is my second magnet. તો એનું મારે મેગ્નેટિક ફિલ્ડ શોધી કાઢવાનું. અહીંયા આગળ સાઉથ અને નોર્થ ફોર એક્ઝામ્પલ છે. તો મેગ્નેટિક મોમેન્ટની ડાયરેક્શન કેવી હશે? આવી હશે મેગ્નેટિક ફિલ્ડની ડાયરેક્શન. This is B1 and this is suppose north and south. તો આની ફિલ્ડ કેવું છે? મેગ્નેટિક મોમેન્ટ આ ડાયરેક્શનમાં છે, M2. This is M2, this is M1. તો અહીંયા એંગલ કેટલો છે? 90 ડિગ્રી. So now torque is acting because torque is equal to mv sin theta. Torque is equal to mv sin theta. So torque is acting. અને જો પોટેન્શિયલ એનર્જીની કેલ્ક્યુલેશન કરું તો પોટેન્શિયલ એનર્જીમાં થીટા મારો કેટલો આવશે? 90. પોટેન્શિયલ એનર્જી, what is the formula? M dot b with negative sign. So mv cos 90, so it is 0. So potential energy is 0 here. And torque is acting. અહીંયા torque 0 છે. આગળની વાત કરીએ એમાં બી torque કેવો હતો? 0. તો આ કોન્સેપ્ટનો યુઝ કરીને આપણે શું કરી શકીએ? ફોર્સ શોધી શકીએ. અહીંયા ફોર્સ લાગવાનો પ્રશ્ન જ નથી. કેમ કે u is equal to minus m. This is 0. તો આનો કોઈ ડિફરન્શિએશન થવાનો પ્રશ્ન નથી. પણ ટોર્ક અહીંયા લાગશે કે ટોર્ક is equal to m2 cross b1. Okay, so torque is not equal 0. Here torque is 0. તો આવી રીતે આપણે સિચ્યુએશન સંભાળી શકીએ. ઓકે, find the magnetic field and magnetic potential due to a short dipole magnetic moment root 5 ampere meter square at a point 2 meter away from it, direction 45 degree. So in this solution we have magnetic moment m is equal to root 5 ampere into meter square and distance is 2 meters and angle is equal to 45 degree. So we have b is equal to mu 0 upon 4 pi m upon dq and root of 3 cos square theta plus 1. Our basic formula છે at angle theta. This is your magnet, south, north, and this is the point. This is theta. So mu 0 is, so it tends to minus 7, the 4 pi cancel. M is equal to root 5 upon dq, so 2 raised to q. And then 3 cos square theta, 3 cos 45, okay, plus 1. So this is root 5 divided by 8 into 10 raised to minus 7 and root of this cos square root 45. So the cos 45 means 1 over root 2 square, so 2. So 3 by 2, 3 by 2 plus 1 means 5 by 2. Okay. So whatever you get, that is in Tesla. You simplify this. And second thing, potential. So potential is equal to mu 0 upon 4 pi m cos theta upon dq. Okay, so Again, this is 10 raised to minus 7. M is root 5 cos 45 degree divided by 2 raised to q. So you simplify, that is your answer.